Welcome back. We are on to Chapter 2, which I think is pretty exciting because Chapter 1 was a lot of refreshers, arithmetic, which we've been doing since first grade or so. So now we're really getting into what pre-algebra should be, expanding on things that you might be familiar with already, but really pushing into what you're going to need to know when you go into beginning level algebra. So starting off with the chapter, once again, just like chapter 1, we have this 24 game. And if you've forgotten, the idea of this game is that you use these 4 numbers and you can add, subtract, multiply, or divide to make 24. So if you want to give this a shot and see if you can come up with the answer for these, go ahead and pause this here. And then I'll go over the answers for these. All right, so this first one here, let's see, you can do 10 divided by 2 would be 5, plus 7 would be 12, times 2 would be 24. This next one here, we can do 9 minus 2 would be 7, times 2 is 14, or plus 10 would be 24. This one here, this one looks very familiar to, I think it was also the third one in chapter 1. Very similar to that one. I don't think it's the same one, but it's very similar. So for this we can do, again, very similar answer, where we go up to 46 or so. So we do 21 plus 2 would be 23, and yeah, times 2 would be 46, minus 22 would be 24. All right, and then this last one, there's actually a few solutions to this last one here. The one I like is 9 minus 7 is 2, times 13 is 26, minus 2 would be 24. There's a couple other solutions to this if you want to find the other ones also, if you found a different one. But anyways, jumping into chapter 2, we're going to be talking about exponents. So a refresher for exponents, or if this is your first time with exponents, you are familiar with multiplication already. We went over that. So let's say you have something like 2 times 4. We talked about this before in the last chapter, that multiplication is just repeated addition. So really what this is saying is that we're going to do 2, we're going to add 2 4 times. So 2 plus 2, plus 2, plus 2. We're going to add 2 4 times. So we get 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. It's going to equal 8. So 2 times 4 is 8. So just like multiplication is repeated addition, exponents are going to be repeated multiplication. So 2 to the 6th means that we're going to do 2 times 6, or 2 times 2, times 2, times 2, times 2, times 2, 6 times. All right, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and times 2 would be 64. So 2 to the 6th would be 64. All right, so here's a whole bunch of squares. So this is section 2.1, which is on squares. And why is it called squares? It's to the second power, and it's called squares because a square has equal base and height. So that's going to be multiplying something by itself. So whatever the base is, you can do that squared to get the area of the square. I'm assuming that you've talked about area a little bit before this course here. An area is going to be base times height. For a rectangle and for a square, the base and the height are the same. So that's going to be any of the sides squared. So if you start from anywhere, if you say this is the base and this is the height, for example, if you kind of just looked sideways, it's going to be the same. So this here is a 5 by 5 square. So it would be 5 squared, which would be 25 right here. And if you were to count these squares up, you would count 25 squares. All right. So for memorization, I would suggest you probably memorize up to 12, but you've probably done that for your times tables anyways. I'm guessing you probably already have these squares memorized, but if you don't, these would be some good ones to memorize. It would just make your calculations just a little bit faster. Beyond that, I don't think you really need to memorize those squares. Calculating them doesn't take too long, and these are going to be some very common ones you're going to see a lot. So I would say definitely memorize these squares, but the rest don't worry too much if you don't have those memorized. Maybe a few common ones here and there. 15 squared might come up here and there. Some of the easy ones like 20 squared, you kind of should just know off the top of your head. But anyways, that's a general idea. So down here, we have a reminder of order of operations. So there's a couple acronyms that you might have seen for order of operations. The one I'm used to is PEMDAS, PEMDAS. Some other countries, you might see some other variations like something like this one. So PEMDAS is parentheses, and then exponents, multiplication, division, addition, subtraction. This is the order of operations. This is the order that you need to compute your equations. This one, if you're curious, stands for brackets. The O could stand for either order or of. Basically, is going to be your exponents here. Then division, multiplication, addition, subtraction. So you see that here, this is multiplication, division, and this is division, multiplication. So these here are interchangeable, just like these here are interchangeable. As we found out in chapter 1, multiplication and division are really kind of the same operation. At least they can be converted to the same operation. Division can be converted to multiplication because division, all division really is multiplying the reciprocal. All subtraction is adding the negation. So these operations can sort of be treated as the same. So if we have an expression with multiplication and division, you can do either one you want first. The order doesn't matter. So you could actually, if you wanted to, you could rewrite this. Instead of PEMDAS, you could do PE. The order of those matters. You'd always have to do parentheses first, always do exponents first. But then here, you could do division first, and you could do subtraction first. All right? So it's not exact when it comes to these here. It's whatever order is easiest. But these here are important. The grouping matters, so you have to do multiplication and division before you do addition and subtraction. Anyways, so yeah, evaluate the expressions inside parentheses, compute the powers, multiply and divide from left to right, and add and subtract from left to right. All right, so now on to our problem. So 2.1, simplify this here. Go ahead and pause the video and see if you can give this problem a shot. All right, so I'm going to compute the square first. The square is 2 squared. And why do we compute the square first? Because that's our order of operations. There's no parentheses. Are there exponents? Yes, there is. So that's what we need to do first. So we have this expression right here. So first thing that we need to do is compute the square. So 2 squared is the same thing as 2 times 2, and that's going to be 4. All right, now that we have that, now we can go ahead and, what's the next operation? So we have this. We have 180 minus 5 times 4. Do we do 180 minus 5 first? No, of course we don't, because if we remember our acronym here, I should really start writing with my writing pad instead of my mouse, but it's been working so far, so we'll go with it. So let's see, parentheses, we don't have any of those. Exponents, we're done with those. Multiplication, division is next. All right, so we have that. So we have 5 times 4, and that's 20. So that's why we have 180 minus 20. And now all we have left is subtraction, and that's going to be 160. All right, next one. What is the value of 2x plus 5 squared? Note the parentheses where those are. When x equals 3. In other words, in the expression in parentheses 2x plus 5, all squared, replace the x with 3 and evaluate the new expression. So you've probably had problems like this before prior to this course. I mean, this is algebra right here, where you have these variables and you're inputting values for these variables. But you likely have seen expressions like this where you have to plug in different values for variables. If you haven't, and this is your first time, then it's fairly straightforward. Anytime you see an x, we're going to put a 3. So let's go ahead and do that. Let's replace the x with a 3. And when I say replace the x with a 3, I don't mean that this 2 turns into 23. we can't just put a 3 there because this is really saying 2 times x. So when we put the 3 in there, it's going to be 2 times 3. So there we go. We have 2 times 3, and we'll leave everything else the same, plus 5 squared. All right, so now we have to compute our parentheses first. So inside of our parentheses, one thing to note also, that let's say we have parentheses inside parentheses. Usually if you have parentheses inside, let's say we have 2 plus 3 times 4, let's say. So we have parentheses inside parentheses. When this happens, typically on the outer parentheses, you won't use parentheses, you'll use square brackets. It'll look like this. You can find that key on your keyboard too if you want to type it. And then the inner parentheses would look like this. So I wanted to point that out real quick. And then so the outer bracket. So then you can tell like this belongs with this. And then the inner one, those belong together. All right, so, but anyways, when you have parentheses in an expression, then you have to follow the order of operations once again within the parentheses. So here, we want to evaluate what's inside these brackets first, but then in this expression, what do we want to evaluate first? Well, we have parentheses, so we have to evaluate the parentheses first. Hopefully that makes sense. So in this case here, we evaluate the parentheses first, but within the parentheses, we have to do the multiplication first. Now it happens to be on the left side of the expression anyways, but if it was, say, 5 plus 2 times 3, we would still do the 2 times 3 first. So 2 times 3 is going to be 6. We have 6 times 5, and then that's going to end up being 11 squared, or 121. So hopefully that's what you got. Also, if you follow the order of operations, that's what you should get. Yeah, pretty straightforward there. Okay, so evaluate negative 12 in parentheses squared, and how are negative a squared and negative a squared related? Note the parentheses. Go ahead and give this one a shot. Okay, first let's write the square as a product. So what I mean by that is if you have 6 squared, the product of that is going to be 6 times 6, right? That's what 6 squared means. So let's go ahead and do that with this negative 12 in parentheses squared. So this negative 12 in parentheses squared becomes negative 12 times negative 12. We're going to be squaring what's in this parentheses. So negative 12 times negative 12. All right, and we know from last chapter that when you have a negative and a negative, that becomes a positive. You can extract out the negative ones. And then you have 12 times 12. And then these negative ones cancel out, and you're left with 12 times 12 right there. And we know 12 times 12, or 12 squared, is going to be 144. All right, so I meant to say, is not the same as a squared. I remember writing this slide, and I was like, I need to make sure I write the word not there, and I missed it. So negative a squared is not the same as, oh wait, oh, okay, I misread. I'm thinking about another question. Okay. So negative a squared is the same as a squared, because look, you get 144, which would have been the same if we had done 12 squared, right? 12 squared is 144, and negative 12 squared is 144. Sorry for that mix up. Yeah, so they are both the same. And the reason that they're both the same is because a negative times a negative is a positive. So if you square the negative, you're going to get a positive again. Squares will always be non-negative. You can't ever have a square that's negative. So you do, negative a squared, and you're going to get a squared. You're going to get positive a squared. You will never get a negative. Now, I said non-negative. I didn't say it will always be positive. Actually, I might have just said it would be positive, but it will not always be positive. The only exception to that is 0. It could be a 0 squared will equal 0, because 0 times 0 is 0, and 0 is not positive, but it will never be negative. All right, so 2.4. What is negative 2 squared. The expression negative 2 squared is the negation of the square of 2. What number does negative 2 squared equal? Yada, yada, yada. Given x equals negative 2, find the value of that expression. So go ahead and read these for yourself and see if you can complete these problems here. All right, I will continue on here. So remember that negative a in parentheses squared is equal to a squared. The negative sign ends up going away. So this negative 2 squared is going to equal 2 squared, and that's going to equal 4. And hopefully you can see why this is the case. The negative signs end up canceling out when you do negative times negative. So then that'll end up being positive 4. But, so here's what I was talking about in the last slide that I got mixed up with. Negative a squared written like this is not the same as negative a squared when you have the negative in parentheses. Why do you think that is? Take a second to think about that. Why those are not the same thing. So we already solved this. We already solved this negative a squared with the parentheses, because this negative a squared really, as a product, would be negative a times negative a, right? And then we could see we have a negative times a negative, and those negatives cancel out, and then we're left with a squared. That's not what this is. So negative a squared, that is saying we are squaring the a. So let's say our a was 3, okay? So if we have negative 3 squared, remember we compute the exponents first. This is multiplication. This is negative 1 times 3. That's multiplication. We do the exponent first. So we do this first. So that is 9. And our negative is still there. So we get negative 9. Whereas if we had negative 3 squared in parentheses, that would have been negative 3 times negative 3, and that would have been positive 9. Hopefully that makes sense. All right, so the expression negative 2 squared is negation of square, what is it? Yeah, okay, so we just did that part. And yeah, so that's what I was saying here. So negative 2 squared is we square the 2, and then we don't lose the negative, so it still remains negative 4. All right, so for this last one here, given x equals negative 2, find the value of this expression here. So let's go ahead and, just like we did in the last problem, plug in negative 2 for all the x variables. Remember, we're multiplying any time that we see this x. It's 2 times x squared. So 2 times negative 2 squared plus 3 times negative 2 plus 4. All right, so what do we do first in this expression here? We're definitely not going to add first. We have these exponents right here, so that seems like a good one to do first. So negative 2 squared, or negative 2 times negative 2, is going to be positive 4. And that's what we get here. So now we're left with 2 times positive 4. And then 3 times negative 2, a positive times a negative is going to be a negative. So we do plus negative 6, and then plus 4. All right, so now we can do this multiplication, right? 2 times 4 is 8. Plus, we still have our plus negative 6 and plus 4. So now we can do our addition and subtraction. Well, if you remember that plus a negation is the same thing as minus. So this is the same thing as saying 8 minus 6 plus 4. And we'll just do our addition and subtraction left to right. So we'll do 8 minus 6 is 2. And 2 plus 4 would be 6. All right, so for the next one. Explain why 8 times 125 squared is equal to 8 squared times 125 squared. And how does part A help us compute that quickly? Give that a shot. All right, first go ahead and rewrite this as a product. So 8 times 125 all squared. It's going to end up being 8 times 25 multiplied twice, right? 8 times 125 times 8 times 125. Remember your parentheses. You can't lose track of your parentheses. But we can use the commutative and associative properties now. This is all multiplication. This is going to be 8 times 125 times 8 times 125. It's all multiplication everywhere, which means we can use associative and commutative properties. So now we can move things around. Oh, I didn't write that out here, but that's okay, because now we can combine these here, and we can combine these here. So now we have 8 times 8 and 125 times 125, which of course is going to be 8 squared times 125 squared. Running out of room. But that's what we have right here. That's what we were trying to find. Okay, so how does part A help us compute that quickly? So if someone asks you what is 8 squared times 125 squared, well, that might be kind of difficult to multiply 64 times 15,625. I can't do that in my head. So instead of doing that, I know that 8 squared times 125 squared is the same thing as this. 8 times 125 all squared. And 8 times 125, I can do that, because I know that 125 times 2 would be 250. And if I double that, so 425s would be 500, which means 825s would be 1,000. All right, so 8 times 125 would be 1,000. And then 1,000 squared, then I can do that, because 1,000 squared would be a bunch of zeros, a million. Yeah, if you did 1,000 times 1,000, each of those numbers has 3 zeros, and so you just stack on the zeros, so it becomes 6 zeros. All right, so that's a lot easier than doing all this stuff. All right, so important down here, when you have a square of a product, so AB in parentheses squared is going to end up becoming A squared times B squared, because it becomes AB times AB. And when you rearrange it using the commutative and associated properties, it becomes A squared times B squared. All right, now let's try this with fractions. So evaluate 1/7 squared. It's also a reciprocal. All right, so once again, we're going to rewrite this as a product. So that's going to be 1/7 times 1/7. And you can kind of combine this in one fraction here. So 1/7 times 7. And that's going to be equal to 1/7 squared, which is going to be 1/49. So the square of a reciprocal. So if you have a reciprocal, so if you have 1 over something, you really just are going to square the denominator. And what we'll get into later is that, because we haven't really talked too much about fractions that are a number other than 1 in the numerator and doing multiplication with that, but just to work ahead a little bit, if we have something like 2/3 times, let's say, 4/5, really what we would do is just we would multiply across. So it would end up being 2 times 4 is 8, over 3 times 5 is 15. We just multiply across. Right here, we have just 1 times 1, so that just stays 1. But you would end up squaring the top also. Just in this case of a fraction with 1 in the numerator, then you're going to be left with 1 after you square it also. Okay, to explain why 7,224 divided by 12 all squared is equal to this. So same thing as before, but now we're using division to see if, the same thing that we can do for multiplication also works for division. So let's go ahead and do this one. So so first thing we want to do here is convert the division to multiplication. So remember, division is the same thing as multiplying the reciprocal. So we have 7,224 now times the reciprocal of 12, which is 1/12. And that's going to be squared. So we know that from the previous problems that when you square something like this, and that's the same thing as saying 7,224 squared times 1/12 squared. All right, so now we can go ahead and delete these. Now we can convert it back to division, because we're multiplying a reciprocal, so now we just flip that back to division. So we have 7224 squared divided by 12 squared, because the reciprocal of the reciprocal is back to the number. So anyways, that's what we were looking for right here. And so we were trying to prove that we can kind of do the same thing we do with multiplication, where this multiplication, or this exponent sort of distributes, not exactly distributing because this isn't addition or subtraction, but this square does go to both of these variables right here. So a divided by b all squared ends up becoming a squared divided by b squared, and that works. There is a video right here. I'll put a link in the description, and I suggest you go and watch that just for additional content. All right, so let's solve these three problems right here. Again, go ahead and pause this and give it a shot. At this point, you should have a good idea of how these are working and how we're going to be expanding these out. So for the first one, we have 5 plus 6 all squared. Again, so we want to work with the parentheses first. So 5 plus 6 is 11. We have 11 squared, and that's going to be 121. So now the second one was the value of 5 squared plus 6 squared. Well, 5 squared is 25. 6 squared is 36. Add them together, and they are 61. So turns out that this here is not the same as this here. So I mentioned that in this problem, I said this is kind of like distributing, but not actually, because this isn't addition or subtraction. Actual distribution is not possible. So there's no like distributive property when it comes to exponents. You can't distribute this squared to the 5 and the 6, because you get the wrong answer. And the reason for that is because that's not what you're doing here. When you say 5 plus 6 squared, you're not saying 5 squared plus 6 squared. You're saying 5 plus 6 times 5 plus 6. That's what you're actually doing. You're not doing 5 squared plus 6 squared. And if you notice here, one of the earlier problems, we expanded it out like this, but it was all multiplication. So we were able to use the commutative property and the associative property to bring these together and say something like 5 times 5, and then it'd be 5 squared times 6 squared, but that's when we had multiplication in the center. Right now we have addition, so we cannot do this. We cannot use commutative and associative properties when it's a cross addition. It's only when it's all multiplication or when it's all addition, but not mixed and match. So they're not the same. If A and B are non-zero, then this is not equal to this. All right, moving on. All right, so using the picture on the right, explain why 8 squared is equal to this. And then, pretty similar, explain why this is true. And then finally, what is 901 squared? So we take this one at a time, and then by the time you get to C, this shouldn't really be a problem. So go ahead and see if you can come up with answers for this. This one's a little bit trickier, so take your time with this one. All right, so explain why 8 squared is equal to this junk here. All right, so we know what 8 squared is, right? We have this square here. That's 8 by 8. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8. It's an 8 by 8 square. And we know an 8 by 8 square is going to be have an area of 64. If you count all these squares up, it's going to be 64 of them in there. We can also see these bold lines here. And so this is going to be 7, right? 1 less than 8. And there's going to be 7 here. So there's going to be a 7 by 7 square. So if we have this 7 by 7 square, what else do we need? So we have the 7 by 7 square, but we also have this extra stuff here, right? We have this stuff right here, which how many blocks is that going to be? It's going to be 7 blocks. And this is going to be 7 blocks here. So that's 2 7s. There's a 7 here and a 7 here. So that's 2 7s. And what are we left with? This 1 here in the corner. So now we're left with that 1. So that's why they are equivalent. So, and we can we can do this math real quick just to make sure that it all adds up. So 8 squared we know is going to be 64. But this expression right here, so 7 squared plus 2 times 7 plus 1, 7 squared is 49. 2 times 7 is 14. And let's see, so we have 40 plus 10, that's 50. 9 plus 4 is 13, so that's going to be 63. Plus 1 is 64. All right, so 64 and then 8 squared is 64. So they match, it worked. All right, so using that idea, let's try the same thing for B. So explain why 901 squared is equal to that. So if you just imagine, so I know 901 square is going to be much bigger than this one, but you can imagine a square that's that big. And then you can also imagine that top layer, you just slice off that top layer, then you'll have two 900s. You'll have a 900 here, and you'll have a 900 here, and then you'll be left with one in the corner. So you'll have two 900s, you'll have your 900 square, and then one more, and all that's going to create the bigger 901 square. But this is a little bit easier to compute because these are powers of 100. So those are much easier to compute than trying to find 901 squared. Let's go ahead and do that. So 900 squared plus 2 times 900 plus 1. So 900 squared is going to be 9 times 9 is 81, and then 4 zeros, so 81 and 4 zeros. 900 times 2 is going to be 1800, and then plus 1. So then we have in the 100,000s we have an 8, in the 10,000s we have a 1, in the 1,000s we have a 1, and then 800, and then a 1 in the 1 position. So 811, 801. All right, so now we know how to go from one perfect square to the next. Anytime we have any number here, any A, and then, okay, so we have A plus 1. So in this case, like, for example, the 901, and we square that, then that's equivalent to the 900 squared plus 2 times 900 plus 1. So we can kind of bounce from one square to the next square, or in reverse, if we had something like 899, then we can bounce to the 900 square from that. All right, so also there's a video for this one. Go ahead and check that out. So this is kind of just some bonus content right here. This is something that is addressed in the end of section exercises, but we'll talk about this a little bit because it's super important, so I want to make sure I cover it here. So try to explain why this here becomes this. The reason why I think this is so important is because as you get into higher level of maths, you're going to have to work with variables to create some more generic expressions that always work for everything. So you need to be able to be comfortable with working with variables sometimes, and sort of back away from the need to always be working with specific numbers to have an exact answer, because sometimes the answer that you want is just another expression. And that's the case in this, because this is an important expression that you're going to see a lot. So let's go ahead and clear this and work through this a little bit. All right, so we have, let's work up here. We have A plus B squared, right? And what does A plus B squared mean? That means A plus B times A plus B. Remember from the last slide, this does not mean A squared plus B squared. That is much different, and that would not get us the right answer. What this is saying is all of this has to be squared. A plus B times A plus B. All right, so how do you multiply this together? Well, if you've done this before, then you already know. But what do we already know? We know about the distributive property. We know if we have something like A times A plus B, then we can distribute that here. And then we ended up getting A squared plus BA, right? But here we have two expressions here. So if we were to split that up, let's see how we can do this and make it a little bit more visible. I mean, so basically the answer is that you distribute both. You distribute the A and you distribute the B. So you might have seen the acronym FOIL. This is what I've always liked to use to make sure I don't forget anything, because there's always 4 steps here and you can't forget any of them. So let me go ahead and erase these lines here. And this stands for first, outer, inner, last. Now you don't have to do it in this order, but this is just something that I like to tell myself so that I won't forget any of them. If I always go in the same order, I know I will never forget one, but you don't have to go in this order. So first is you match up the first numbers from each of these pairs. So A times A would be first, and that would be A squared. All right, next one would be outer. So outer would be the outer numbers, A times B. So A times B would be AB, so plus AB. Okay, and now inner, now B times A, so plus BA. And finally, last is going to be B times B, which would be B squared. All right, so AB and BA, those look pretty similar. They're just swapped in the wrong order. But remember, multiplication is commutative, so we can change the order. So instead of saying BA, let's just say AB. And we have 2 of these now, right? AB plus AB. Well, what do you do if you are adding something twice? That's the same thing as multiplying by 2, right? So this would be the same thing as saying A squared plus 2AB, there's 2 of those, 2 of these ABs, plus B squared. And there we go, we expanded that expression. And as you can see, that matches right there. So it's gonna be really important. We're gonna be using that, this here, a lot in algebra. All right, and that's it for exponents. Go ahead and do the 2.1 exercises, and I'll see you next time for 2.2.